Okay. So, number 3, find the margin of error for a 90% confidence interval when the standard deviation is 50 and sample size is n, or is 25. What is our answer? Did everyone get an answer?
I got 16.5.
Don't you have to round to 3 decimals?
Oh, so add 2 zeros to it.
Actually, I got 16.45.
Did you round? Did you use 1.645 or 1.65?
What did I use? I used all of them. The 4, 6. I can double check.
Because I didn't actually know which one to use because I used both, and one will be 16.5 and the other will be 16.45.
Which one's the 4, 5?
The 4.5 is using 1.645. I just figured you would round it to 2 decimal points because for 95%, you always use the 1.96. But I don't really know.
Well, I think because if you were to put it in the applet for both of them, you only get 1.960. So there is no other decimal for either one of those.
Yeah, so we can just go with the 4.5.
Okay. So which of the following statements is true? What do you guys think? Would it be X bar is the point estimator for you?
That's what I'm thinking.
Okay. So now using this information, what is the point estimate for the true GMAT score?
526.
Yeah, that's what I put. Okay. What is the margin of error for a 95% confidence interval for the true GMAT score? Just let me know when you get an answer.
JC, did you get it?
Do you have to plug it in to the applet? I mean, after you find.
No.
I keep getting weird numbers. So what exactly are you guys?
Um,
The margin of error equation is m equals z, which is the z-score for 95%. And then that is times with the standard deviation divided by the sample number with the square root.
Okay. So to do the z-score, did you do do you find 95% of
Yeah,
or
that little z, whatever that z is whatever the, like, it's the 0.196.
oh,
So he was given, or we were given 3. We used the 95% one, which is 1.96.
oh.
You should get something like 27, I think.
yeah.
Okay, sorry. So you take the z-score, which is just the 526 divided by the 113, or divided by the 113 over the square root of 64.
So it would be your 1.96 times the standard deviation divided by the square root of the sample size.
So 27.685.
Yeah, that's what I got.
And so if it asked for like the 99, you just use the other number that's assigned there instead of the 1.96.
Yeah.
So that one would be like 2.5 something.
Yeah, something like that.
Okay, so what is the lower limit of the confidence interval? Casey, did you get that one?
A second.
I got 498.315.
That's what I got. You got to do that one, JC?
No, I think I read the wrong stuff.
No.
Sorry, guys.
So when you find the lower or upper limit, it's the x bar plus or minus the margin of error, which was the z-score times standard deviation over square root of sample mean. So we, in our last question, got the margin of error.
Mm-hmm.
So to find the lower one, it would be the X bar, so the mean of the sample, minus the margin of error.
Okay, so the 498.315.
Yeah.
Okay.
And then to find the upper limit, you just add it instead of minus.
Okay. So 553.685.
Yep.
Yeah.
Okay. What would happen to the width of the confidence interval to the sample size?
If the sample size increased, the width would decrease.
Decrease.
Yeah.
What would happen if you changed it to a 99% confidence interval?
The width would increase.
Increase.
Okay. So with this information, what sample size do we need?
Which, JC, that has an equation to it. And it's just n equals z, the z-score times the standard deviation divided by the margin of error. And then that's squared.
Margin of error squared.
No, everything,
The whole thing's squared.
part of it is squared.
Yeah. So it's z times standard deviation all over the margin of error. And then all of that is squared.
Okay.
Yeah.
And the margin of error is the 1.96 times the standard deviation divided by the square root of, or times by the square root of the sample size.
Yes, but the margin of error they want for this is 50 hours.
Because in the question, it gives you the margin of error.
Yeah.
So we're looking for the square root of, or we're looking for the sample size. N.
Okay.
So I got 245. Or 246.
246 is what I got.
Yeah. Because with that one, you always round up. Okay. So with all this information, what is the lower limit of this 95% confidence interval?
So that's where you do margin of error, or your mean minus the margin of error.
Yeah.
And margin of error is equal to the
The z-score times the standard deviation divided by the sample means, or the square root of sample mean.
whoops. So I got 99001.533.
And then round that to the nearest whole number, so 99002. Yep.
Okay. What is the upper limit? So yeah, you just, you can figure it out.
So 122,999 or 998.
Yeah. Okay. There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are all of the above, right?
All of the above.
I don't really understand that question. Like,
It's a
Yeah.
cheap one.
there's 3 answers,
Yeah.
and there's only 3 choices.
Yeah. It's great.
Logic would tell you. Probability wise.
Yeah.
For number 3, did we decide 16.450? Or is that
Yeah.
Yeah, I think
Okay.
we'll just, yeah. Okay. 100%.
we thanks guys for explaining that to me. I don't know. I did not read that stuff.
Wait.
Okay. So do you understand it more, JC?
Yeah, it makes sense.
Okay. For this, basically you just have to remember those 3 equations.
Yeah, after you have the equations, it makes total sense. But I just hadn't seen those equations before, so
Wait,
thank you guys
what
for.
did you guys give for question 8?
8? Oh, I already X'd it out of it.
No. Oh well.
It was 553.685.
So 553.685?
Yeah.
Yeah.
Oh, I just forgot the 3. Okay, whatever.
Oh.
Stupid. Okay. Well. So you got everything now?
Yeah, it makes lots more sense. I'm gonna go read what I was actually supposed to read.
Okay.
Okay.
And if 10 works for you guys on Thursday,
Yeah.
Yeah.
thanks for meeting later.
No problem.
Yeah, no worries.
Okay, perfect.
Okay.
Yeah.
I'll see you next. See ya.